All right. So we're starting a new series. We're dealing with indices. On this journey, we're going to be looking at the laws of indices, how to apply the laws of indices, the exponential equations, and just play around the concept of indices, basically. All right, let's start with the laws of indices. Laws of indices. The first law we have says that if I have x raised to the power of a multiplied by x raised to the power of b, that would be the same as x raised to the power of a plus b. So in essence, I'm saying if they have the same base and they you're multiplying them, you just need to add up the powers. So look at this. If I have 2 raised to the power of 3 multiplied by 2 raised to the power of 4, this is going to give you 2. Notice that the bases here are the same. 2 raised to the power of 3 plus 4. And that's going to give you 2 raised to the power of 7. Of course, we can do it in another way just to show that that is correct. 2 raised to the power of 3 times 2 raised to the power of 4. Now, this here is equal to 2 multiplied by 2 multiplied by 2. And this here will be 2 multiplied by 2 multiplied by 2 multiplied by 2. Notice here that we have 1, 2, 3, 4, 5, 6, 7. That's going to give you 2 to the power of 7. So notice that we have the same results as in this way. So this law works. Then it's not always going to be straightforward like that. You could have another example. Let's have an example 2. What if you were given 2 raised to the power of 4 multiplied by 4 raised to the power of 2? Did you notice here that the bases are not the same? So when we have a problem like that, what we need to do is to find a way to bring it to the same base. So we can have this as 2 to the power of 4 multiplied by 2 to the power of 2 raised to the power of 2. So notice that 4 is 2 raised to the power of 2. So of course, this is another law, and we'll get there. When we have the power of the power, I will explain better. But when you see something like this, just multiply the powers here. So we have 2 raised to the power of 4 multiplied by 2 raised to the power of 4, because 2 times 2 here is 2. And that's going to give you 2 raised to the power of 4 plus 4. And that's 2 to the power of 8. That's what this is for the first law. The second law is similar to the first law. The second law says that if I have x to the power of a divided by x to the power of b, since they have the same base, what we just need to do is to subtract the powers. So that's a minus b. That's going to give you an example like this. Let's say you're asked to simplify 2 to the power of 5 divided by 2 to the power of 3. Of course, this is going to give you 2 to the power of 5 minus 3. This is 2 raised to the power of 2. Or you can go the traditional way, the long method, and say 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. That's 2 raised to the power of 5 divided by 2 multiplied by 2 multiplied by 2 multiplied by 2. And okay, 2 raised to the power of 3. So this cuts this cuts this out. This also cuts this out. And what you have left is 2 times 2, which is 2 raised to the power of 2. Of course, this is equal to 4. This is also equal to 4. So notice that the law works perfectly. Let's take one more example and we move to the next law. Another example is 5 to the power of 2 divided by 5 to the power of minus 4. This is the same as it's the same as 5 raised to the power of 2 minus 4. Notice there's a minus here already, and then because of this division, we introduce this minus here. So this is 5 raised to the power of 2 plus 4, and that's equal to 5 raised to the power of 6. You can expand this if you want, but this works just fine. Let's go to the third law. The third law is the zero index law. Zero index. What this means is that x to the power of 0 is going to give you 1, provided that x is not equal to 0. So what I'm saying, this implies that the 0 raised to the power of 0 cannot give you 1. But every other number goes minus 1, 2 raised to the power of 0. It will work perfectly, provided that x is not 0. Even if x is a fraction, it will still work. So let's solve this. An example. Let's say we have 3 raised to the power of 3 divided by 3 raised to the power of 3. Notice here that this is the same as saying 3 raised to the power of 3 minus 3, and that's going to give you 3 to the power of 0, and that's going to give you 1. So basically, whenever you see something like this, 7 raised to the power of 0 is equal to 1, 5 raised to the power of 0 is equal to 1, even variables, even a million raised to the power of 0, it's still 1. If I say Abel raised to the power of 0, I'm still saying 1. Basically, provided that Abel here is not 0. So let's go to the fourth law. The fourth law. The fourth law is what I like to call the product law. So what that says is that if I have a power of a power, this is the same as x raised to the power a multiplied by b. Notice there's a power inside and there's a power outside. It's different from the first law. It's different from the first law where both of them are exposed. But in this case, one is inside a bracket and the other one is outside. And when you have something like this, you multiply the powers. So this is the same thing as x raised to the power a b. And the law can also be applied this way. We can have x y raised to the power of a. This is the same as x raised to the power of a y raised to the power of a. What that means is that so long as they are joined by a times here, a multiplication sign here, you can spread this power across. But note that the law does not work for something like this: x plus y raised to the power a. You cannot say this is x raised to the power a plus y raised to the power a. That's not correct. This is wrong. So let's use the law. Let's have 2 raised to the power 3. Then another power outside. This is going to give you 2 raised to the power 3 times 2. So this is 2 raised to the power 6. That settles it. Let's have another example. Example 2. Let's have 3 raised to 3 times 4 raised to the power of 2. Of course, this is going to give you, you can decide to say 3 times 4 is 12, and then you say 12 raised to the power 2. And this is going to give you 144. Or you can spread the powers across. Since this is not a plus, this is a times, you can say 3 raised to the power 2 multiplied by 4 raised to the power 2. And this is going to give you 8. This is going to give you 9. 9 multiplied by 16. 9 multiplied by 16. And this is still going to give you 144. So that still settles it. Let's have one more example here, because this will be the last law I'm going to be explaining in this video. I've done 4 laws, and in my next post, I'll be posting some questions that you can solve. All right, so let's take one more example. Let's have 3xy raised to the power of 3. This same as 3 to the power of 3, x to the power of 3, y to the power of 3. Do you notice this? 3 raised to the power of 3 is what? 27. So 27x cubed, y cubed. That's basically how to use that law. Okay. So in the next video, I'm going to be dealing with fractional index, and I'm going to also deal with exponential equations. Thank you. See you in the next video. Don't forget to like, follow, subscribe to this page, and just share to others so they can also learn how to do basic mathematics like this.